All right, Sharks, this is Mr. O with Layers of the Earth and Plate Tectonic Key Vocab. I know vocab is not the most exciting thing in the world. However, it is essential with knowing each of our content strands as we go through. So we will start each unit off with front loading all the vocab and quizzing you on it as we go. And essentially, if you can understand the vocab, you can mostly apply it to understand other things. So as we go, if your definition doesn't match mine identically, it's okay. However, you make sure you have the main ideas of each of my slides. I try to keep them as short and brief as possible. I also included brief illustrations to show you what I'm talking about in each slide. So first with the inner core. So we're starting from the center of the earth out. The inner core has three main things you need to know. It is the innermost layer of the earth, meaning if you went to the center, you are in the inner core, hence inner. It is made of solid metal. It is so hot and pressurized that metal actually solidifies, and is also the most dense layer. You have to know the most and least dense, and the inner core is the most dense. Now, the type of metal, there's iron, there's other such metals, but in 6th grade, you just need to know it's solid metal. The next is the outer core. The outer core surrounds the inner core. That's why it's called the outer core, because it's the outermost part of the core. This is when the metal begins to liquefy, and it's liquid metal, so it's composed, or its composition is liquid metal, and it has convection currents in it because it's a liquid. The convection currents in the outer core is one of the two reasons for the Earth's magnetic field. Don't confuse magnetic field with gravity. I don't know why, but often kids confuse those two, but the magnetic field has nothing to do with gravity, so keep that in mind. Third layer is the mantle. Big things about the mantle. It's the thickest layer of Earth. It's slightly larger than the outer core. It's made of liquid rock, but really it's made of semi-solid rock, but either one is acceptable to me. The different types of rock doesn't really matter in 6th grade, so you just need to know it's liquid or semi-solid rock. And this is the other layer that has convection currents. But these convection currents cause plate tectonics to move. So each layer that has convection currents, their currents cause something different. So make sure you note which ones do what. You'll need to know that later. The crust is the fourth major layer. It is known as the thinnest layer and the least dense layer, and it's made of solid rock. Obviously it's solid. You're standing on the crust right now. If the crust was liquid, you would slip right into the earth. That just doesn't make sense. The crust is super, super thin compared to the rest of the earth. When you're looking at your apple experiment, this is why the apple skin is a good model for the crust of the earth. So 4 major layers: crust, mantle, outer core, inner core. You do need to know the order. You do need to know which one's thickest and thinnest. You do need to know which one's least and most dense. And you do need to know what they're composed of. So it goes solid rock, liquid metal, solid metal. The next is the lithosphere. It is one of 2 sublayers. Sublayers means it's part of layers. It's not a whole layer. The lithosphere is actually quite special. These are what the tectonic plates are. The lithosphere identifies where those tectonic plates are. I like the picture because it calls them the lithospheric plates instead of calling them tectonic plates. The lithosphere is made up of the crust and just a little bit of the upper mantle. So keep that in mind. When you hear the word lithosphere, think tectonic plates. It's not a major layer, it's a sub-layer, which means part of a layer. The second sub-layer you need to know in 6th grade is the asthenosphere. This is in just the upper mantle. It sits just below the lithosphere. If you can look in the illustration, you see the lithosphere in gray, and then the asthenosphere sits just below that. And that's the layer that the tectonic plates essentially float on. They're floating on this liquid rock. This is why the Earth is constantly moving, because the plates are sitting on top of semi-solid rock. So 2 sublayers, lithosphere and asthenosphere. The next word is composition. This is a general definition. You're going to see this in every unit we study. So this is one word you better get to know real fast. Composition, root word is compose, which is to make. So composition by definition means what is something is made out of. I put the picture of a cookie there because a cookie is made out of several things. And without having several ingredients, you wouldn't have a proper cookie. But to tell me what it's composed of, you'd have to tell me flour, sugar, baking soda, baking powder, chocolate chips, All those are part of its composition. The next is a property of matter, which is density. The reason why we use this word in this unit because we talk about the least and most dense layers of the earth. Remember, most dense layer, inner core, least dense crust. What we mean by that is there's a formula to it. You take the mass of an object and you divide it by its volume, and that's how you find its density. In normal terms, it means how many atoms are in something. So if there's a lot of atoms in something, there is really dense. If there's not a lot of atoms, not so dense. For example, the air is a lot less dense than your desk. The next is tectonic plate. What you need to know is there's two types of tectonic plates. There's oceanic and continental. If you are Captain Obvious, just like myself, you'd understand the oceanic plates are under the ocean and continental plates are around land. Earth is completely covered in the plates, and the illustration I showed you above, right under the key word, shows how the entire world is covered in these different plates. Some are significantly larger than others, and some are quite actually small. And we'll talk more about those boundaries when we get into plate tectonics. Tectonics, however, is talking about how the plates are always moving by the convection currents in the mantle. What you need to know in this is general. You just need to know the plates move from a few centimeters to an inch per year, which doesn't seem like a lot, but a few centimeters can cause mass destruction if you know anything about earthquakes. So, plate tectonics, and then tectonics is the action of the plate. So that's where the difference between those two words are. The magnetic field, we just went over this in class a little bit ago. There are two causes of the magnetic field. One, you have to have the convection currents in the outer core. It's because the outer core has liquid magnetic metal, and that metal is spinning. Also, the Earth rotates on its axis. So not only do we have magnetic metal spinning in the center of the Earth, we also have the Earth itself spinning. Those two combined create what's Earth's magnetic field. Essentially is how a compass works. Convection current. We will get into this later when we get into the wave and heat transfer unit. However, we have convection currents in the mantle and we also have them in the outer core. The convection current is what you see on the right. It's a heat transfer in either an air, liquid, or semi-solid. We need to know in this unit that it happens in the mantle and the outer core. And essentially, heat rises and cooler heat or cool falls and making a circular motion, and that circular motion causes other things to happen. Next is seismologist. Anytime you see the word ologist in science, it means a person who studies something. It just depends on what the prefix on that word is. In this case, it's seismic. So seismologist is a person who studies earthquakes, and believe it or not, they use a seismograph. These words start to make sense once you understand that seismic waves are earthquake waves. Seismologist studies earthquakes. They use a seismograph to do so. And a picture shows you a seismograph and the different types of waves and how they are studied. Seismic wave. These are waves given off by earthquakes. There are three types of seismic waves. You have P waves, I know, haha. But P waves really mean primary waves. You have S waves, which means secondary waves. And then you have surface waves, which is the waves that we actually judge earthquakes by on Earth, because it's the ones we actually see the damage from. Then we have three boundaries to finish off these notes. You have a convergent boundary, which is probably the most complicated because there's several different types. But a boundary is where two plates meet. Remember those plate tectonics? You saw that picture of all the different plates and stuff like that. When these two plates meet, they will push in or into each other or against each other, meaning they will collide. And there's two different types of convergent boundaries. It's collision or subduction. Collision means is when they hit head on, just like a car collision or a football collision. But then there's also subduction, means one will go below another one. And you also need to know that old crust is destroyed at these boundaries. You have divergent boundary, which is a boundary where two plates meet and the plates will move away from each other, meaning they will basically run away from each other. I always refer to it as myself, if I encounter a skunk, I will diverge away from that skunk. I will run away. But because of that, new crust is formed, because you can see in that picture that magma, which is liquid rock inside the earth, will fill in the gap where those two separated and form new land, which means new crust. And the last boundary, I think, is the easiest boundary to know, is this transform boundary. And it's a boundary where two plates meet, because it's a boundary. And these plates slide or scrape past one another. I always refer to it as a road, like they're driving next to each other. Crust is neither formed or destroyed because it's not pushing into each other or pulling away from. They simply just scrape. And the major thing from this boundary is where earthquakes come from. Remember, with any flip notes, you are able to go back, pause, redo, rewind, watch as many times as you want. But make sure you have all of these words correctly identified with an image on your notes, ready for next class. Thank you very much. See you soon.